Now I want to integrate it with the atmosphere lighting in a less hacky way than I'm currently doing it. So currently I'm just taking the average color underneath it, the average scene color underneath it, and using that. But I want to move the cloud logic into a copy of the atmosphere shader, change the atmosphere shader to return a float 4 instead of a float 3, where the fourth value will be the light map, which is just going to be a gradient of the presence of light in the atmosphere, and then I want to integrate that with the clouds. So to start that, let's create a clone of our atmosphere shader. This is our current atmosphere shader here. And to start this, let's go ahead and just get all of this stuff out of here. All of this stuff out of here. This stuff out of here. All right, great. So here's our atmosphere shader. So we're going to need to change this a bit. So let's go ahead and do that. So we already returned a float forward main image, but we have this just one here that we don't really need. So how do we want to do this? Render scene is also returning a float 4. So I think we need to change skylight and calculate scattering to return float 4. So we're going to do that. So let's take a look at our calculate scattering. Change this to float 4. Come down here, take a look at our return function here. So we can see that this is where we're combining with our scene color. And this appears to be our light function. So let's try float 4, float 3, light. Right? I guess we'll keep it on multi-lines. And then we can replace this block, light function plus scene color times opacity, except we want to return a float 4 now. So float 4, yeah, we already changed it. So we can do return float 4. This is already a float 3. And what we'll do is take our light function dot x plus light function dot y plus light function dot z. We'll average out pixel value. All right. And then our skylight will also return a float 4, and that's all we should have to change because it's already returning calculate scattering. And then our float 4 render scene. This is a loop. color. Yeah, so let's make sure we're not using that W value anywhere. We are not. So we should be safe to get rid of this because it's not being used. Actually, a little bit confused by this. We just do color plus equals clamp of this. Turn the color. Scene equals render scene. Color equals. Is this the right function? I might be in the wrong function. I have to check because I don't see the scene color getting passed down. Oh my god, it's such a pain. Well, if it's the right function, then this should be fine. Yeah, it wasn't the right function. All right, where is my correct function then? Here? Yeah, this is it. Okay, I was in the wrong place. Okay, so you're gonna be foot four. You're gonna be foot four. Yes, this is correct. Okay, great. And then you can do the same thing. Dot x plus light density dot y plus light density dot z divided by 3. All right, now we're in the right place. I was like, this doesn't seem right. I can get rid of this. It's also tempting while we're in here to try and find a way to basically have this output without needing the scene color. I'm not sure if we'd be able to, but like right here is where it seems to be composited. If this is the only place that we use it, it's not. It's also used in scattering. But like you could just return 0 here, right? Return 0, and then figure out the compositing externally, which would be nice to not have the compositing happen in here. But for now, we're just going to try and find the light density map. So, all right, so we've changed this to return this float, and then float for skylight is just returning scattering anyway. Float for render scene, color equals this empty color. Um, 0, 0. Color plus equals the output here. Render scene. Color plus equals scattering. And then we just return call dot xyz equals 1 minus x call xyz. And then we just return call. Yep. All right, let's give this a shot. So back over here in our editor, we have our nice settings all set up to work in the editor. Okay, kind of expected. Can I initialize return object type of vector float 4, the L value type vector float 3, return, oh, yeah. Check all our returns of scene color. Scene color. Look for scene color, and if there's no intersect with the atmosphere, our light density should be 0. Look for scene color. We can also improve this atmosphere shader with the same lessons we learned from our cloud shader. Um, Basically, what we realized is that when we're tracing through two shells, it's more of a pain in the ass, but it's way more efficient from like a step calculation standpoint to calculate two trace segments rather than if it's like crossing the shell in two places rather than one big one, because a huge amount of the samples in the middle aren't used. So we'll have to think about that. But for now, let's try and get this light density out. Okay, float 3 skylight and color. 3 skylight. So float 4. Okay. No, no, no. That was fine. Alright. It's another bug down. Plus the truncation, color plus calculate scattering. Call plus equals calculate scattering. All right, so now we're outputting float 4, and our atmosphere hasn't changed its appearance any, which is good. Break out float 4, but we want to check the light density. That seems like light density to me. How about you? Okay, great. Now we're going to be doing all sorts of experiments with this today. I'm going to try to isolate. Ideally, I could isolate just the added light from the atmosphere without integrating it with the scene color and integrate it with the scene color out here because it's really inflexible to have to pass in the scene color to this function. Um, but now that we've got this, let's save this. Go to content drawer, grab our cloud prototype function. Copy this whole block. This goes into transmittance. Ah, fuck. It exploded. It's dead, Jim. Alright, so it exploded. But basically, we have our light function now. We want to integrate that with our cloud shader. Yep, I do want to open up those editors, please. Make this bigger, take this over here. Alright, so first things first, let's change some of these values to get it closer to our float 3. What's 160 times 50? Calculator. Like 8,000? Alright, I'm just gonna try it. Get our cloud prototype stuff over back in here. Save it since it crashed last time we tried to swap the cable out. Absorption. Absorption plugs into our. No. Not absorption. Transmittance plugs into our alpha. Okay. Let's take a look at this. But we're gonna want like a floor on this, so let's go ahead and plus 0.05 clamp. Fuck me. God damn it. We may not actually need our height fall off for the clouds if we're using this methodology. Is possible. Okay. Alright, let's try this again. So U plus 0.05 clamp down here. Plug you into transmittance. Okay, beautiful. Plug you into emissive color. Actually, hang on. Where's my scene color? Alright, so we're going to plug our existing output here. And then we're going to plug this in. Come on, don't crash. Okay, it's closer. Now let's take a look at our instance of the atmosphere and figure out how to get those fuzzy edges that we had. We're going to copy these settings into our defaults. Okay. Absorption fall off. 0.4. Height is whatever height me 0.05. Height Raleigh 0.1. And now you have to turn up our atmosphere height a whole bunch. There we go, baby. All right. let's turn down our max radius here. 70, 180, and now 1800, so that all the clouds fall within the lit areas of the atmosphere. And hey, we've already got some like dark clouds. We're on the dark side of the planet. Steps is at 8. Density steps 32. Oh wait. This is the clouds. Meant to be doing this stuff to the atmosphere. It's going to get a little confusing. Height. Absorption, fall off. G is 0.7. Height absorption is 3. Ambient glow is replaced with ambient beta, so we can actually get rid of this. Light intensity at 40. Light steps at 8. I wonder if we could go lower with light steps. The atmosphere. We can probably make the atmosphere a lot faster as well. Planet radius at 8,000 is correct. Let's change these. So, if our planet radius is 8,000, we want to divide these by 50. Because we're using that as a scalar so that we can go 1-to-1 with our planet units. Well, that does mean these all need to change. It's 50 times 50. All right, now let's bring it in. All right, well, let's try it. Material instance. There we go. Where's our current cloud volume? Okay, it's this guy. So let's turn off our atmosphere layer. Let's take this guy, change his material to this. And then let's pop open this. No, not you. Pop open this and change our Planet radius, min max radius, atmosphere height. One uh, times 0.15. All right, well, we have to figure out where our clouds are at. Oh, oops. There we go. All right, so our max radius is a bit too much. Actually, 0.5. 0.1. All right. Well, that's light integrated into the clouds. Let's see how they look up close. They're a little too low. A little too low to the ground. So we need a little bit more height. Oops. Come on. Save it. All right. Now I got some nice clouds. I mean, we need to tune the default parameters of the clouds themselves a bit. The absorption needs to be bumped up. Try like a 0.7. Darkness threshold, maybe. I'm curious about the clouds in this kind of transitional range. And also the nighttime clouds. Let's get under these. I mean, those look pretty good nighttime clouds for nighttime. They look pretty good for nighttime clouds, I should say. Alright, so the next thing I want to try out only thing about this is the scene color propagating through this whole thing is annoying. Let's render the light density again here with our updated parameters. Also, let's save everything. File, save all. That certainly looks like the light density to me. I mean, at the very least, that's a basic cloud layer here. So next we're gonna want to figure out a way to get some of the color impacting the thing. So I am curious. Density plus scene color times opacity. All right, I want to try this. Um, let's save. Let's also make a commit so we can restore if we get too far down the rabbit hole. Needed atmosphere function to What happens if I do this? If I do this, if I do this, it works, right? No, I fucked it up. Shit. Alright, undo, undo, there. Take this whole thing back over to here. Am I in the right function again? Wait, no, 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 no. No, 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 no. No wonder I fucked it up. Alright. Pasted it into the wrong function. That will definitely mess it up. Alright, let's try to get rid of this. Just want to see. How does it look like this with no scene color input? Every reference is scene color. Aha. We would really prefer to do the scene color compositing outside of the shader if possible. It gives us more precise control over it, and like it gives us better like interaction with things like the cloud color only taking on the atmosphere color attributes. Um, all right, so then with the clouds, it would look like this, right? And then if we wanted to blend that with the scene color, we could maybe lerp it with this. Need a quick component mask, RGB. May have to switch these cables. Okay, that's not exactly right. That is not exactly right. We need that opacity value we were calculating to make it out here too. just add them. How's that look? Too bright. But then what if I did a 1 minus exponential? Exponential. Times negative 1 minus. Give that a shot. No, 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 no. Not good enough, unfortunately. Not good enough. So we're going to have to play around with the atmosphere, but we are returning. Pretty good looking atmosphere only view. We can also make our, I'm pretty sure we can make our atmosphere shader better, faster, if we incorporate the ray logic from our cloud shader that uses shells to restrict the area that we're ray marching through, because we don't need to ray march this whole thing. We only need to ray march um, the area outside the planet, right? All right, let's save this and just see how that looks, because I want to see how the skylighting is affecting the ground. Okay, so this is where the skylighting is what's providing us the kind of shading, right? I really want to be able to incorporate, like some of the settings here obviously need to change. I want to be able to incorporate the sky color somewhat into the color of the clouds so that when you're in like a sunset zone, you get like some nice, um, like reds and oranges in the clouds rather than just gray. And part of that is kind of isolating all this stuff out. We would do something like take this atmosphere color plus our light color, divide it by maybe 1.5 and clamp it, and then use that as our light color to get a bit of color contribution from the atmosphere into the clouds. Does seem to work, sort of. There's still some stuff to fix here, but we're getting there. I really need to be able to. Can I? I can't. Can I have another output? Yes, so we can make an additional output. So I need to walk my dogs and go get some lunch and take care of some errands and stuff. Um, so this is gonna be it for right now, but I'll come back later today and continue working on this. I think we're close. I want to be able to get rid of the scene color input to my atmosphere, do our compositing outside so that we have just just the atmosphere data in one place, just the cloud data in one place, combine the two. I think I may have given up on the idea of integrating the both ray marching loops because they're using drastically different numbers of steps. I need more steps to do the clouds than I need to do the atmosphere. So I'm not sure that's gonna. Oh, yeah, that's starting to get real nice. Um, so yeah, I mean this is big progress. We're gonna keep going too. All right, later.